Hello students, welcome to chapter 13, limits and derivative. Today I going ahead in your exercise 13.1, question number 24. Related our rule for sandwich rule. Yes, left hand side limits and right hand side limits, if they are same for a particular x is equal to a belongs to r, then the limit is exist. Then related we going ahead 24. Find the limits for the x tends to 1 fx for fx is given. So students, here two cases given, one of the more than, one of the less than, and also given the equal. So I just start if x less than 1, then x tends to 1 minus. In the minus case, what you get the fx? 1 to below number? Yes, x square minus 1. And go to limit x tends to 1 less than function. X tends to 1 less than function, I have to x square minus 1. Just put down x is equal to 1. Never put minus 1. They only indicate minus what? This minus indicates it is a left hand side limit. I just putting your value is 1. My answer is 0. Same as if x more than 1, then x tends to 1 positive. So which function is given in your questions more than 1? Minus x square minus 1. So limit x tends to 1 positive. You easily operate your functions in place of x. X is equal to 1 minus x square minus 1. So 1 square minus 1. Check, they are same? No, not same. And third case, at exactly x is equal to 1, you have to know fx are equal to, that is the x square minus 1. So f1, 1 square, it is 0. Now check, all three data are equal, then the limit is exist. That's the saying to our sandwich rule. That is not same. So I will showing limit x tends to our part 1 less than, not equal to. Similarly, limit x tends to 1 positive fx and not equal to f1. So by sandwich rule, I just saying that here limit does not exist. Yes, so limit x tends to 1 fx does not exist. And here easily this question is done, students. Now I will go to quantify. This is the IMP for exam. If fx is equal to given modulus x by x, and here 0, they are never 0, but here is equal to 0. And question asking, find the limits for x tends to 0. Then find limit x tends to 0 fx. It's a simple question, but in modulus they have two cases, one of the positive, one of the negative. So I will start my solution from here, x never 0. So if x never 0, it means, students, there are two meaning, one positive, one negative. So x less than 0, otherwise x more than 0. So here I create my two types of solutions. One of the modulus x is equal to minus x, modulus x is equal to plus x, and fx I will create to modulus x by x, which is only minus 1. Similarly, right hand side, fx become modulus x by x, which is x by x, but it is only 1. Now I will start my limits. So limit x tends to 0 negative functions. If you going to left hand side limits, limit my function is minus 1. It's covered to minus 1 answer. Similarly here, students, limit x tends to 1 positive functions. X tends to 1 positive function, it is 1. That is the 1. Now check, it is same as? No, it's not same. So my limit is does not exist. And I also showing at x is equal to 0, also applying my limits. It's easy way. So less than 0, more than 0, not same. And also I will show that at x is equal to 0. My fx is a 0. f0 is a 0. You check the all answer are same? No. So therefore limit x tends to 0 less than function is not equal to 0 more than function is not equal to f0. So that's why I telling that by sandwich rule you will just cover to your answer limit x tends to 0 fx does not exist. Now question number 26 is same as students IMP question. So related 25 is just reciprocal that question given. If fx x by modulus x never 0 is equal to 0 and question is that find the limits for regarding x tends to 0 fx. Find limit of x tends to 0 fx. Same calculations, only just factors are denominator is reciprocal the question number 25. So same as I going I start the questions. If x never 0, definitely I have x less than 0, otherwise x more than 0. And here you will create two partitions and easily you will decide it your answer in the two partitions way it is exist or not. So first of all modulus x minus x plus x. What's your fx? X by modulus x. So I will show here x by modulus x. It is minus x minus 1. Same as here. But it is 1 only. So limit x tends to 0 less than function. Limit less than function have answer what? Minus 1. So my answer is minus 1. Same as here. Limit 0 positive function. Limit 0 positive function is a 1 and they are not same. And third case at x is equal to 0 fx becomes 0 f0 equal to 0. Indirectly I will telling here not exist limit by the rule of sandwich theorem. Simple, easily you decide your answer part. So after that I just going. So limit x tends to 0 less than fx is not equal to x tends to 0 positive fx is not equal to f0. Again check all data are never same. This answer is 1. Therefore I last decide by sandwich rule limit x tends to 0 fx does not exist. And that's your easily and happily students this question is done. Now 27 which is IMP questions for exam level. Limit asking that x tends to 5 fx find if the function given only and only modulus x minus 5. Students here modulus case available in the two case positive or negative. But we decided at place of x equal to 5 it is indirectly more than 0. So here I will start that at x is equal to 5 definitely it is x more than 0. So modulus x is only and only x you just cover. So I start one by one. First if x tends to 5 less than fx cover modulus x minus 5 but only that x write down because x more than 0 modulus x is 5. Which term is more than 0? 5 indicate x tends to 5 but minus they indicate only left hand side but my value is 5. So limit x tends to 5 negative functions limit 5 negative is x minus 5. 5 minus 5, answer is 0. Same create now in positive sides. Here I write down. This answer also maybe if you same, then my limit is exist, otherwise not. So I will continue. Similarly, if x tends to 5 positive cases, same is apply. My of x modulus x minus 5. It is only x minus 5 because x more than 0, because I will take 5 number. So modulus x only x. That's why limit x tends to 5 positive functions. Limit x tends to 5 positive functions. And the positive functions value internally x minus 5. It should be 0. And you check this left hand side, right hand side are same. And third case is at x is equal to 5. Direct put down if you, then also you will get your answers is 0. It means by sandwich theorem limit is exist. So x tends to 5 negative functions, x tends to 5 positive functions is equal to Fy are same as. So I will just telling by sandwich rule, limit x tends to 5 fx is exist, and how much it is? It is exactly, yes, exactly it is a 0. Next, 28. Also IMP and many time asking in the final exam. Question number 28. Find a and b if the function is given a plus bx 4 b minus ax x less than 1 equal 1 and more than 1, and also given if limit x tends to 1 fx is equal to f1, then you decided your value for a and b are available in the which cases. So students, here already given that, it means what? Limit is exist. So you will just cover easily here, apply your sandwich rule. Left hand side, right hand side we will equal taking at x equal to 1 and decide easily value for a and b. So students, I apply here sandwich rule. So in this case there are the two cases are available. One of the limit x tends to 1 less than fx. Second, limit x tends to 1 positive fx, and last it is f1. Now 1 less than, it's the cover to a plus bx. So I just apply my function a plus bx. Secondly, in the 1 plus, it is limit 1 positive, the x is more than 1 cases is b minus ax, and last exactly f1, it is the case is 4. Now you just putting the limits, only put x is equal to 1, students, never put minus 1. Same here, b, a is 1, so my a plus b, b minus a is equal to 4, and here I decided two equal equations, and then after elimination you will get easily your answer, students. So a plus b is equal to 4, and secondly same is going a b minus a is equal to 4. So does here take simple our LCM forming, and then after answers, so that I cancel a and a, twice b, 4 and 4 8, b become 4. That's my first answer. And also you will cover to a plus b is equal to 4, a plus 4 is equal to 4. So your answer is a is equal to 0. So there are possible values, students, a 0 and b 4. Here easily we decide, and 3 marks easily I get in that. Now students, continue question number 29. This is the only logical sum to 29. If for a real number a1, a2, a3 dot 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 an are the fixed real numbers and also given fx is the x minus a1 comma into x minus a2, x minus a3 till last x minus an, and also given, then find out limit x tends to a1 fx. Find. Also, if given that for some a not equal to a1, a2, a3, an, then find limit x tends to a fx. So very easy and simple. You just using the simple two solutions here one by one, students. First of all, I decided limit fx function x tends to a1. Only this I explain first. So very easy. Limit x tends to a1 fx. Putting your value for fx. My fx is a fixed at x minus a1, x minus a2, x minus an, and putting only x plus a1, a1 minus a1, a1 minus a2, a1 minus an, and that is answer 0 into a1 minus a2. This is a 0, students. Dash last a1 minus an, this become answer 0. Limit x tends to a1 fx. That is the first case done. Now second, given that if a not equal to a1, a2, a3, an. So my target is here x tends to a of fx, and putting down your value for x in place of fx. So limit x tends to a. What's your fx? X minus a1, x minus a2, and x minus an. Just apply x is a a1 value. So apply a minus a1 dot, a minus a2 dot, a minus a3 dot, last a minus an, and that should be your final answer, because here no further calculations, they are not same. So that's why here this ending this sum, and here happily students this question also done. Now continue question number 30. Yes, 30 is a IMP for different angle questions given. Find the possible value of a if the limit is exist for the given functions. Yes, question number 30. This is also IMP. Find possible value of a if limit x tends to fx is exist for fx modulus x plus 1, 0, and modulus x minus 1. Condition is there less than 0, equal 0, and more than 0. Students, here condition given depend on x is equal to 0 and asking what is the possible value of a. So first of all, I check at place x is equal to 0. So at x is equal to 0, we decide first if x less than 0, then x tends to 0 negative. What the function your exactly x is equal to 0, less than 0, this one, mod x plus 1. It means here you will take modulus x minus x. So here minus x plus 1, and limit decided x tends to 0 negative fx. Your limit is decision easily here, minus x plus 1. Putting down your 0, your answer is only and only 1. Now second case, if x more than 0, then x tends to, students, 0 positive. So what is the modulus x? And which case I will prefer to in questions? Yes, second one. Fx become modulus x minus 1. So it is only you have to x minus 1. And same apply in the limits. So limit x tends to 0 positive. X tends to 0 positive. And my fx is here x minus 1. 0 minus 1. Check. These are same? No, not same. And third, exactly given at x is equal to 0, fx becomes 0, f0 becomes 0. Indirectly, I just telling that this is not a same. So limit 0 less than fx is not equal to limit 0 plus fx is not equal to f0. So finally at x plus 0, limit does not exist by sandwich rule. So indirectly I just here half numerical is easily done. So by sandwich rule, what the going sandwich rule? Yes, limit x tends to 0 less than fx, I mean direct right, limit x tends to 0 fx does not exist. But in question given, if a limit x tends to fx exists, then find possible value of a. It means a never takes 0. Therefore, if limit x tends to fx is exist, then possible value of a is never 0. It means other than 0. So a belongs to r minus 0 in the any real number, but 0 not taking in this answers. Now continue question 31. 31 also one of the logical sum, students. So for a function fx, limit x tends to 1, fx minus 2 by x square minus 1 is equal to pi is satisfied, then find yes. Then limit x tends to 1, fx, find out x tends to 1 fx. Students, whenever if your limits is exist, pi given, any given pi place, limit is exist, then here x minus 1 is a factor of numerator and denominator. So I will start my numerical. If limit is exist, then it is necessary, then here x minus 1, according to that, x minus 1 is factor of numerator and denominator. So this factor I will utilizations in the numerator. Already denominator, see students, given that factor is. So your answer is convert that. Check here, x square minus 1. There is a two factors, x minus 1 and x plus 1. Already written I. So in numerator wise also I taking factor. Now students, if you factor, then remainder is 0. So therefore we will take fx minus 2 is equal to 0 remainder, and here putting from that x is 1, your f1 is a 2. Now last, our target is limit x tends to 1 fx, limit x tends to 1 fx, or only I put down there f1. And what is f1? f1 is only and only 2, and that's over here students sum. Now 32. is also logical sum. Yes, completely logical questions again asking by the rule by sandwich theorem. If fx mx square plus n, second nx plus m, n x cube plus m, 0x less than 0, second 0 less than x less than or equal to 1, and x more than 1. Then find for integers m and m. Find integer value m and n. If there are two questions, limit x tends to 0 fx and limit x tends to 1 fx is exist. Yes, both of the limit is exist. So exist limit means sandwich rule already they apply and they are possibility to available answer. So I will start one by one case. First of all, x tends to 0 fx. So if our first case, limit x tends to 0 fx, limit is exist, it means limit x tends to 0 less than fx is equal to limit x tends to 0 plus fx and is equal to f0. Directly you will cover to sandwich rule if a limit exists. Now x tends to 0, exactly 0 is less than means this case, limit x tends to 0 less than, it's covered to mx square plus n. Now 0 plus is that, it is a more than 1. So here write down limit 0 plus, it is nx plus m, and exactly 0, again telling that n x plus m, but x you put down the 0, so m into 0 square, n into 0, here same as, so my answer is n is equal to m is equal to m. Indirectly your first answer is whenever you n is equal to m, my answer is limit is exist for limit x tends to 0 fx. And second case, if this limit now x tends to 1 fx, limit is exist, so here also same case, limit x tends to 1 less than fx is equal to 1 more than fx and is equal to students f1, and you decided in simple way x tends to 1 less than fx means this functions, more than 1 means here this functions, and last exactly f1 means again this functions. So 1 less than functions I will decide it here that nx plus m, exactly f1 more than that, limit x tends to 1 plus, that is n x cube plus m, and exactly f1 again nx plus m, that you create your value for n1 plus m, and my answer is n 1 plus m 1 cube plus m. It means students n and m for any our integer value, because they are same, n plus m is equal to, so what is the possible value of m and n? Any integer. Yes, so possible value of m and n for any real number. Yes, any real number. So any cases you will take m and n, that you get the answer, students. Students, here 32 questions up to this part already done, students, and our exercise also over. So students, I will stop this video, and in further explanations to next level going, we have to limits and derivative in the next parts. Bye bye.